change in volume of the system does not alter which of the following equilibria, right? Now let us take for example this equation. N2 plus 3H2 is giving twice of NH3 basically, right? The question, this is basically a typing mistake, right? Now what is happening if I talk about Kc, equilibrium constant? These are all reactions are all in equilibrium, right? So this will give you what? Kc will be equal to what? Number of moles of NH3 divided by volume into whole square divided by of number of moles of N2 divided by volume into number of moles of H2 divided by volume whole cube, right? If I have to cancel out the volume, this is the volume of the vessel, right? So I can rewrite it as number of moles of NH3 whole square divided by of number of moles of N2 into number of moles of H2 whole square, right? So it will be V raised to power 4, that means V square will be there. Now if I change the volume, what will happen? Obviously the equilibrium will have to shift somewhere, right? So we have to find a reaction in which this part, this V, comes out to be 0, right? V raised to power 0 basically, or 1. This comes out to be 1, that means V raised to power 0. That means this has to be 0. Now what was actually this? This, power was the number of products, the number of reactants minus products, right? So that means the coefficients, the sum of coefficients of the reactants should be equal to the sum of coefficient of the products, so that this comes out to be 0, right? Now if I see equation C, let us suppose over here there was a difference of 2, right? Basically the reactants were more. The sum of coefficients was 4, the sum of reactants, the products was 2. So that means the end result was 2. That is why it was coming out to be V square. In the D equation, the sum of the stoichiometric coefficient of products is 2, of reactants is 1. That means there will be a difference. That means it will come out to be V raised to power of minus 1, right? In option B also there will be V raised to power of minus 1. It is similar to D. But in A, if we see the coefficient, the stoichiometric coefficients of reactants and products are equal, that is 2 and 2. That means it will come out to be V raised to power 0. That means in case of A, in A, Kc will be equal to what? Number of moles of NO divided by V whole square divided by number of moles of N2 divided by V into number of moles of O2 divided by V. So if we cancel out V from denominator and numerator, we will get number of moles of NO whole square divided by number of moles of N2 into number of moles of O2. Now there will not be any term of V, right? So that means in this kind of a reaction, if we change the volume, there will be no effect on the equilibrium. It will remain the same. That means option A is correct.